So thanks, Irene. It's very fun to be here. I've really enjoyed this conference. Everybody's really friendly, and it's a totally different community than I'm used to. And it's been really enlightening. I love how everybody's paying attention and not like totally, academic conferences. People get a little bit distracted and come in and out and stuff. So this has been really refreshing. So as Irene said, I'm a professor of computer science. It is a little bit true that when you get your PhD, you get a little bit more out of touch with the hands-on stuff. But I'm going to tell you today about some of the work that I've been doing in my lab with my students, one of whom is here. Our research area is really around linguistic information visualization is what I call it. So looking at language data and how we can interpret documents and understand document collections. We also have some work in visualization technique and interaction design. And thanks, Arvin, for the shout out to our DimFizz project. That's one example of that kind of work that we do. We also do some work with natural user interfaces, tables, walls, that kind of stuff. But I'll talk to you today about the visualization research. So first I want to try and skewer a little bit some of the concepts that we see in the media about the information overload. So in my grant applications, I'm a bit guilty of this too, right? We say, oh, there's so much linguistic information. What are we going to do? We need to solve it. And so things like this. 2010, with the amount of information online, it is very easy for people to drown in useless information that they do not need in their business or in their lives. If you try to absorb all the information you can find online, then you will experience social media overload. But of course, this isn't the first comment like this, right? You can go back a little bit further. 1967, one of the effects of living with electric information is that we live habitually in a state of information overload. There's always more that you can cope with. And this, of course, is Marshall McLuhan's famous quote. Let's go back even a little bit further. 1755, as long as the centuries continue to unfold, the number of books will grow continually, and one can predict that a time will come when it will be almost as difficult to learn anything from books as from the study of the whole universe. It will be almost as convenient to search for some bit of truth concealed in nature as it will be to find it hidden away in the immense multitude of bound volumes. It gets even worse. We have reason to fear that the number of books which grows every day in a prodigious fashion will make the following centuries fall into a state as barbarous as the centuries that followed the fall of the Roman Empire. How's that for drama? I should put some of this in my grant applications. So I would say don't panic. Solutions have also been around for a long time. Utility of lexicon comes not from reading it from beginning to end, which would be more tedious than useful, but from consulting it from time to time. And of course, this is one of the early examples of an encyclopedia, which you would consult instead of read. Also techniques such as cutting and pasting, creating an index for yourself, understanding the document's structure through a personalized system. Charles Sorrell, 1673, the greatest secret is to make marks for different kinds of passages, crosses, circles, half circles, numbers, letters, and other characters which had the various meanings one had assigned to them. So this is a personal process of annotation that allows somebody to understand a document. So the real problem is not and never has been the wealth of information. The problem is the lack of appropriate tools for filtering, exploration, annotation, and collaboration. The pace of information dissemination exceeds the pace of tool and technique development, and we're always catching up. And that's just me today. So visualization has also been used for text for a long period of time. So this is a more literal sort of drawing of a visualization, but these beautiful visualizations of Bible stories from Clarence Larkin really depict the kind of possibilities that are out there if we really delve into a document deeply. And of course, a lot of researchers in this field outside of my lab have also been looking at this over the past few years, and including before when I started working in this field in about 2007. So what kind of language data are we looking at? We're looking at possibilities for things like understanding culture and society, understanding the history of English literature, looking at the history of the court system, business analytics, of course, sentiment analysis, these kind of things. These are all under the field of language data analysis that I'm working in. However, and thanks to Marty Hurst for this example, visualization is not really a replacement for reading. What do you think this book is? First impressions. Goldilocks, right? Goldilocks and the Three Bears. In fact, it's the soliloquy, to be or not to be, from the nunnery scene in Hamlet. So we do have this problem of a multitude of books, but I don't think visualization is going to solve the problem of having to read them, I'm sorry to tell you. But what I'm here to tell you about today is how visualization can help us find what to read. And I think this can operate on a bunch of different levels. So we start off at the level of text. We have multiple corpora. So we might have multiple different websites or multiple different collections of documents. We could go all the way down into a single document or a section of a single document down to the form of the letters and the typography. And anywhere along this hierarchy, we also might have metadata at each level. So it's a really challenging problem. So what I want to sort of propose today is that if we can make a visualization at one of these levels, we're actually helping people dive down into a lower level to find out what they want to investigate more deeply. So for example, we might visualize a document collection to help somebody find a document of interest. And I'll talk to you about a couple of projects we have in that area. So the first one is called FluxFlow. And this was a project led by a student, Jian Zhao, in collaboration. He was at University of Toronto in collaboration with my lab and some other collaborators. And what we were interested in this project was looking at whether or not we could detect rumors on Twitter. And rumors being maybe also things that were unusual, had unusual propagation patterns. And this was inspired by events that we were seeing where rumors would actually go viral on Twitter. So we saw, for example, sharks swimming down the street during Hurricane Katrina was one. And here are some others from the London riots. So for this project, it had both a sort of a big back-end piece in terms of the linguistic analysis, and we had some help with that, as well as the front-end visualization. On the back end, in terms of detecting anomalies, we had a variety of different features that we used to process all of these tweets. So we collected millions of tweets from a particular event and processed them using a bunch of different features. On a high level, the features were about the user. So for example, is it unusual for this person to be tweeting at this time, or to be retweeting this particular person, or to be using this kind of language that they don't normally use? Tweet trajectory features means things like, is the retweeting volume increasing in a way that's unusual? And then also the lexical and semantic features of the tweet itself. So we were looking at retweeting patterns, and we created these retweet thread glyphs and graphs. So the glyph at the beginning here is a single tweet. And what in there, it represents a few different things. I'm not going to get too much detail into it because I have a bunch of projects to tell you about. But here you're looking at the time since the tweet was posted. The overall color, or the hue of this circle, is the anomaly score, from an orange meaning low anomaly to purple meaning high anomaly. And then the size of it is the volume of the retweeting that's happening. So the pattern across from left to right here then are all the retweets of this tweet. Okay, so each one of these circles is one person retweeting their original tweet. And you can see here that it changes from orange to purple as our classifier is saying that over time this became more unusual. It has a higher anomaly score later in the time period, which is why it's becoming purple. The stuff in the background there is a bit of a artificial intelligence visualization. Shout out to Martin and Fernanda. I don't know if they're still here, but I don't have time to get into too much about that. But it's the hidden states of the algorithm that's doing the classifier is what's the background coloring. So you can see here, for example, on the top, there's a lower anomaly score, a lower volume, and on the bottom, it's a higher anomaly score, a higher volume. So you can play around with this at this bit.ly FluxFlow address if you want. The data set that you'll find there is the Hurricane Katrina. Hurricane Katrina data set. And if we look, I just have a version of it here. Let's see if I can bring that over. So in this version, we can see I've loaded in a few tweets, and this one is one that was given a higher anomaly score, and it's actually, they were talking about the people still standing at the tomb of the unknown soldier in New Orleans during the hurricane, which of course was a rumor. So the way we evaluated this was to look at whether or not humans could do classifications of tweets better using this tool than if they were just reading them. And we used it against a couple of different classifiers, and what we did was pull out the top 500 abnormally ranked tweets and put them into the interface and allowed people to then manually triage them and classify them as rumors or as not rumors. And we found that although the success rates were sort of low, you can see here we were able, ours are the blue bars. For the Hurricane Sandy example, our top ranked anomalous tweet was also ranked by our annotators as being an anomaly or a rumor. But when we started getting down into the top 20, we only had about a 40% accuracy rate. So about 40% of the top 20 anomalous ranked tweets from our system were rumors. However, if you take this in the context of random chance, you'd be choosing 1 out of 500 to try and get whether or not it was anomalous or not. So we're a lot better than random, but still a bit of a problem. So the message to take away here is that we were able to create a system that allowed people to find tweets that they had to read to decide if they were rumors or not, right? The accuracy rate was hovering around between 100 and 40%, depending on what list you were looking at. But it wasn't enough that you could have full confidence. But that said, nobody wanted to go out and read all 3,000 tweets, or 500 tweets, or 5 million tweets, or whatever happens to be. Too much information. So we're looking at here then, can we make a system where somebody can speed up the access to the information of interest? So another project along the same lines that we were working on a few years ago, it was published in 2013, was looking at car accident reports. So in this project, we looked at 600,000 car accident reports, and these are car accidents that were reported to the National Highway Traffic Safety Administration here in the United States. And each of them contained a report of an injury or a death related to the accident. So what we were interested in this project was, could we take those car accident reports and do a bit of a different kind of twist on text visualization by turning it back into the original object that was being discussed? So we made our own ontology of keywords relating to car parts. And to do that, we used Wikipedia and a few other resources together, car part words. With some manual curation, we created this ontology. We also processed the text to find synonyms and things like that. And then we had to do a bit of manual tweaking to pick out problems. For example, first, second, and third are gears, but they're also used a lot in a description of an accident where people will say, first this happened, second this happened. So we had to take those things out. So as usual, you're used to this, some cleaning of the data. We used some stemming. You'll see that coming up now and then. And then we pre-processed all this to put it into a database. The visualization works so that we get, if something doesn't occur at all, we show it as sort of a ghosted image to provide some context about the shape of the vehicle. And then if it does occur, then we play around with some rendering using a hue varying. We really struggled here about whether or not to use lighting effects, because of course the lighting effects modify the way we interpret the color, but they were also necessary in order to distinguish the parts from one another. So there's definitely a design trade-off there. So this is what it looks like. So we can drill down into different years, different makes and manufacturers of the cars. It's all based on a rendering of a vehicle. And then we also have a lens that allows us to look at more details about a particular part of the vehicle. Anything within that lens, we get a time trajectory, sort of matrix plot or heat map about the occurrence of that car part in the accident reports over time. Finally, going along with the theme of the talk, you can drill down and look at the actual documents relating to the part of the car that you've selected, as well as the time period and the make and model model year of the car that you've chosen. So this is all intended to be used on a touchscreen display, but it can also be used in a environment where you're using a mouse. And here's just a video of how it works. So just looking around this car, you can see the various different details. There are too many car parts to show them all at once. And you can also use the little handle that you'll see there happening on the lens, allows you to sort of spin it around and drill down into the car itself. I think that's going to happen now. Yeah, so you can sort of cut away the car to see the internal parts and isolate those parts. So what were we able to find? Well, just as a proof of concept, we were able to see, for example, that the Toyota accelerator pedal issue that was coming up with the Toyota's uncontrolled acceleration, very highly coming up. You can see here just the power, just to go back to some of the stuff we heard yesterday around humanizing and the power of visualization. The power of reading this example, the actual text of it, is so much more viscerally impactful than looking at the visualization. So I really advocate for providing access to the underlying text data. Because it sounds really scary, right? The way that the car just took off and they had no control over it. And that's coming out from isolating the brake pedal and the Toyota. You can see here the huge jump between January and February. It's interesting, actually, the biggest increase in complaints about Toyota cars in this database happened after Toyota announced that there was a problem with the cars. So then people started just jumping on board and complaining about this problem. But we can see, before that, we can still see that there are some issues being reported. So what could we use this for? So things like maybe an ambient visualization at a car manufacturer to see what's happening with the current incoming accident reports. Maybe something that looks at hotel reviews or product reviews where we might want to highlight the parts of the product or the hotel room that are being discussed on social media. Okay, whirlwind tour. Here's another project. So in this case, we were interested in, again, finding documents to read. And this actually was a project from quite a while ago I did with Martin and Fernanda at IBM when I was there as an intern. So in this project, we were interested in the US court system, and our collaborator was particularly interested in the idea of forum shopping. So this means, do people bring a particular type of case to a specific court district because they think that they're going to get a favorable decision in that district? So if you don't know, the US court system is broken down into a series of what are called circuit courts, and they're roughly geographical, and they're numbered here. And then we had, of course, time and also parts of the court cases that we were interested in. So we had the history, bulk download of the history of all of the courts. I won't bore you with the problem of the fact that the data was so messy. Quite a bit of my internship was spent cleaning up this data. But we turned it into a database that we were able to work with. So this is, we were able to detect and separate the parts of the text and then do some typical text analysis techniques like stemming and some stop words. We had a dynamic list that was based on the frequency because we didn't want things like judge and court to be showing up on our visualization. And then we use something called expectation statistics, which I want to talk a little bit about. So if you're doing anything with relation to text, one way that you can look at how a text is interesting is to look at how the text differs from a reference corpus. So for example, if we had the collected works of William Shakespeare, we might have these words as being the most common words. If we had Macbeth, we might have these words being the most common words, the exact same set of words. However, if we use a significance measure, an expectation measure, that looks at what's the likelihood that the occurrence of this word is going to be this high given the reference corpus of William Shakespeare as a reference, then we might now get the more specific words that are related to this particular play. So we did the same thing for the courts. We looked at, given one court and all the rest of the courts as a reference, what are the words that are more distinguishing for that court district? And this is what we found. So notice, first of all, that we have words like Vermont and names like Kearse. This was a bit of a good thing, actually, because it was a sanity check. This is actually what we expect, right? We expect the names of the courts, the judges, the names of the states to appear as the most distinguishing things for that district. So that was great. We knew it was working, so then we took those things out and looked at the more contentful words that we were interested in. So the visualization is basically like a word cloud. However, it's organized into columns which are relating to the different court districts. We have these edge stubs that sort of indicate that a word is significant in multiple court districts. And you can see those here in sort of the light blue. And then if you hover, you get the full edge. So here in this video, sorry about the quality. It's like I said, it's an old video, but you can see just some of the exploration of the details here. So again, getting into the idea of being able to drill down, if you hover on any of the words, you can actually get details about how that word occurs across all of the court districts, because maybe it only occurs in one of the columns. And you can also then see those connections. And finally, you can select terms in order to get the list of cases that contain that term. And you can see here, I'm going to select a few words relating to, this was coming up a lot. It was really interesting to me. These words, I found out later, relate to a disease that coal miners get. And they were bringing workers' compensation cases to the court. So you can see here the details of one of the cases that contains these three terms. And then you can click this and get down into the full details. So what else did we see? Some interesting things like the word ostrich appearing a lot in the Seventh Circuit. I didn't know what was going on. I was looking at this data every day. I'm not a legal expert. And I was wondering, what the heck, like, I thought maybe there's an ostrich farm or something. It turns out, actually, that this is a legal term, and excuse me if I get this wrong, anybody legal experts in the room, that basically it's an instruction that the judge can give to the jury to say, remember that it's no excuse that this person didn't know what they were doing was wrong, right? You can't put your head in the sand. And this was actually used in a case. A famous Canadian was prosecuted here in the United States, and it was used in that case. We also found some interesting patterns. So for example, our drug and narcotic related terms have some weird geographic differences. So methamphetamine in the west versus, what do we have here, narcotics in the northeast. And we don't know, of course, if this is actually meaning that there's more prosecution happening or if it's actually a higher rate of use of these drugs. Okay, so that's document collection to document. So let's look at another project, which is document collections to multi-word collocates. And here what I'm talking about is things that are like phrases, but they're not actually full sentences. And this project is really, was really exciting for us. We were looking at passwords. So passwords are things that we write every day. They mean a lot to us. We know that we're going to be writing them over and over, so we choose them carefully. They're often very personal, and we found that they can be very evocative, right? So they have a lot of potential emotional content. So we had millions of leaked passwords from various different websites. And we were looking, first of all, we were interested, I was working with my colleague Julie Thorpe and Ph.D. student Rafael Veras, and we were thinking about the security implications of if we could detect linguistic patterns in these passwords. And of course, as soon as we started looking at it, I got really excited about also the cultural, like cultural analytics implications, the sociolinguistic implications of this data. So what kind of words do people use in their passwords? Do these patterns represent security vulnerabilities? So can we train a model to learn the types of patterns that people use? And the answer is yes, unfortunately, but it was a very good model. And what did the passwords tell us about society and culture? So the process we undertook was to extract 32 million passwords and parse them to extract the most likely word sequences. And one of the things you'll hear me say a few times is that we use reference corpora. So in this case, we're using the Corpus of Contemporary American English as our reference corpus, which is available. It's unfortunately not free, but it's available online. And to do this, then we categorize the words based on their semantic meaning using a tool called WordNet, and that is available for free online. And then we parsed those results to create a grammar of passwords, basically. And we were able to see that the grammar of passwords is very different than the grammar of regular English. So for example, and this is the visualization, you can find this online. I should have put the URL, but let's see here. Where'd my mouse go? Oh, there you go. Okay, so anyway, so it's my lab website / words and passwords. And on this visualization, we can see that the what you're going to be looking at probably the most is this column, which is the G-squared measure, which is that expectation measure. So every line here is a word, and we're looking at the ranking of the words based on their difference in expectation given English as a reference. So the word that's most common in passwords against English is the letter I. Right? So people talk about themselves a lot in their passwords. The second most common word is love, which was huge. We saw it throughout. It was very unexpected. It was seriously significantly high. And this is hard to do on an IMAX screen while turning around. And then down here you'll see things like a lot of affectionate terms like baby and sexy and love and those things. So we found that people were really interested in playing with this, and the implications were that the language of passwords was very different than the language of English. So I invite you to play around with that a little bit. We were able to use this to create a password cracker, which was the best on a number of different measures. And we were also able to find some really interesting phenomena. For example, animals. Cute animals were way more common than ugly animals, which we sort of would have expected, I guess. But monkeys, cats, for some reason monkey is like the #1 animal. Dolphins, monkeys, cats, and dogs. Emotional verbs like love are extremely common, and in fact, we also found, and this was verified across a couple of data sets, people loved male names 4 times more than female names. And we're not really sure what this means, if it's perhaps heterosexual women writing I love in a male name in their password, or people writing I love myself or something with their own name. We tried to normalize for actually the population of users, but of course we don't always have that information in these leaked data sets, so we weren't able to do that. And also profanity is extremely common, much more than predicted in the sort of canon of security research, where people come into the lab and they're told, please create a password in an experimental setting, and don't worry, it won't be associated with you, but they still don't use profanity nearly as much as they do in their real passwords. So here's just a preview of another visualization I'm going to show you in a second, looking at animal words. These are the animals in the data set. So this got some media coverage. It was fun to collaborate with the New York Times on this article. And then we also looked at some number patterns. So again, this one looking at things like dates. So on the top here we have a calendar, 365 days, and the brightness is, or sorry, the dark blue is more common, a date number pattern that matches that in the password. So 14344, anybody know what that is? It's what is it? I love you very much. I love you very much. Yeah, I love you very much is the number of letters. So it's not actually a date. It's a mistake. But it's what people would write if they were trying to say I love you very much in their password. So again, the most common number pattern is I love you, which is sort of nice, I guess. We also found things like 90210, which is again a mistake, but it's a really common date. But we found some really interesting date patterns as well. So for example, these dates from September 11th, 2001, things like FDNY 91101 and NY 91101. And Twin Towers here as well, TT. Okay, so I packed too much into this, but sorry. I'm getting the okay from here, so I'm going to keep going. So let's see here. So this is a project where we're looking at the document level. So can we look at from the document down into particular segments of the document? So in this project, we looked at, again, the WordNet database and a book. And from there, we go in two directions. So from WordNet, we're extracting an ontology of words, basically the is-a relationship. So water is a liquid. Game is an activity, chair is a furniture. And we're also extracting words from the text and stemming them and bringing those two things together to create a visualization that creates this sunburst diagram where the darker the green, the more common the word is in the text. So it's sort of like a word cloud, but it's organized semantically. The latest research, this is a preview, it's not yet published, but I've got the students' permission to tell you a little bit about it. We're working on right now is a general method for what we're calling uneven tree cuts. So in this technique, and we're going to publish this open source online, is a method for automatically determining what's the initial view that you should show of a large hierarchy. And this is being done with D3. So here we have a tree, and you can see that the yellow and the orange lines are different depth of a tree cut. So if you look at a traditional hierarchy here on the bottom, you normally would get, say, 3 levels of depth. And what our algorithm is doing is using information theory and things like entropy to try and measure what are the characteristics of the data underneath that level. And maybe we should open up some of those lower levels in the initial view because there's something really interesting going on down there. And maybe we should collapse other levels. So here on the top is our version of the initial view. And as we expand out, we see that the traditional view expands everything, and our view actually expands more deeply in some regions and more shallow in other regions to show the data that actually has higher values. So we're really excited about this work. We've submitted it for publication, so hopefully it'll be okay. But the demo I'm going to show you includes some of this. Anybody remember this? So this is a feminist hacker Barbie, who is a response to this awful book, Barbie Becomes a Computer Engineer. And we've got actually some data from Hello Barbie, which is a new Barbie doll that you can talk to, or your child can talk to, I guess. And we have the script of all the things that Hello Barbie can say. So we're interested in this data. It would be great to be able to give it to Kyle to put into his CharNN linguistic generator to see if he could create Barbie language. But we've put it into Docuburst to try and look at some patterns in this data. So here is the word entity. So this is the top level of things that Barbie might say. And again, this is the general version, and then I'm going to switch over to the uneven tree cut version. So this is just a video because for time purposes, I didn't want to mess up the demo. So here is all the words that Barbie can say, the darker things. You can see like she's interested in talking about her friends and her parents, mother and father. She's asking questions a lot too. So the Barbie doll is saying like, how about your parents? What else is here? Food, fun. Of course, it's a toy though, so we can maybe give it a pass for talking about fun and games a lot. But let's drill down a little bit. So if we look in the area of cognition in WordNet, these are the cognition-related words that Hello Barbie will talk about. So kind and right here are a little bit of an anomaly because of the way that those words are used in regular sentences, so it's a bit of a mischaracteristic. But she talks a lot about fashion. And she tries to change the conversation around to say, let's talk about fashion now. How about, okay, we're enough talking about that. Let's talk about fashion. I love fashion. There are so many comments here about fashion in this data set. Let's get a little bit deeper, and we have to really drill in here to try and find where she talks about things like science and math. There's 3 things about physics. So I think there's some response here to try and bring out some diversity in comments, but the fashion is still a really big thing. And I have nothing against fashion. Just thought you might find it interesting. Definitely Barbie's got a different view on math now than she used to, so she's really into math, which is great. And it's fun to see. And let's see where else this goes. So there's one more thing I want to show you. No, they're gray because they're not used. Her favorite color is pink and red. Green is here because of Christmas. She doesn't talk about any other colors though, just pink and red. The absence here means something, so there's no other colors. Let's see, okay, second last example. So look at person words. So person words, she's really interested in medicine, so doctor, dentist, veterinarian, teacher is great. Other related person words, so things like princess is huge. And in here, it's both talking about sort of princess, your Halloween costume princess, but also your princess bedroom, your princess this and that. So there's lots of princess-themed things. And then let's try, I had to look around a little bit to try and find this, but these are all like people-related words, but if we go way down, we can see that she actually does talk about engineering a little bit deep into the data set. Okay, so that's Hello Barbie. It's been fun to work with this data set, and thanks to my student Rafael Veras, who's done this analysis over the past day and a half. I've been Slack messaging back and forth with him to try and get this ready for the talk. So we have an online version. Unfortunately, it's broken. This is one of the things that I'm starting to get used to. When students graduate, I have to maintain things, and it's hard to do. And this was actually using a service called OpenCalais, which was we're using it for name identity recognition, and it recently changed everything, and it's no longer working. So we're going to get it fixed. Okay, I'm way over-ish. 3 minutes, okay. I'm going to read you a quote. Once upon a midnight dreary, while I pondered weak and wary over many a quaint and curious volume of forgotten lore, while I nodded, nearly napping, suddenly there came a tapping, as someone gently rapping at my chamber door. Which one is this? Which bar? Any intuition? Third one, yes. So this is a new project called Lexichrome. My student, so that was Edgar Allan Poe, by the way. Very dark and dreary language. Student Chris Kim, who's here today at the conference, has been working on this project. I'd invite you to check it out. We've been looking at crowdsourced data of how people respond to terms with a color reaction. So what kind of colors do words evoke in people's minds? So we have 12,000 ratings of colors done by our colleague, Seth Mohammed. And we've been turning this into a visualization that allows you to explore the language based on its the colors that it inspires in our minds. So we can look at the agreement levels. So people really strongly agree that cowardly is a really yellow word. Sunshine is even less agreement. Some people say it's red or orange, but cowardly is the most positive. We can look at the language structure. So for example, here you might think, this is available. You can play with it yourself, lexichrome.com. The upper right is not words relating to grass and plants. It's actually greed and money. And the bottom left are words relating to love and affection. So you can explore this and drill down. We also have an editor that allows you to type in your own document and actually replace the words with other synonyms that might evoke a better color that you want to do. So imagining you're an ad executive. This is the Coca-Cola manifesto, and they're talking about refreshing, and we think maybe they might want to change it to the word invigorate in this case to bring out some red feeling in the reading of this document. Other things we're playing around with, just as I wrap up, so we're looking at mapping literature. So looking at, this is 12 Years a Slave, looking at the patterns of movement of characters in a book using open tools to parse the text, things like geonames and Google Maps. Disambiguating locations is a real big issue there, so we've been working on that. What do you do when a place has multiple locations, the same name? And we've got some algorithms for that I don't have time for. And some tools. So some things that we use generally in the lab. Of course, we're doing things like tagging text. Our process includes labeling people, cleaning the data, stemming. Inflection is one that we do. So for example, in the synonym replacement example, refresh to invigorate, if it said cats, we would have to make it dogs and not dogs. So we have to do inflection of the synonyms as well as just the replacement. We often are doing things like partitioning text. We do some topic modeling, calculating scores, those kind of things. We're using some of the same technologies that you've been hearing about over the last couple of days. And we're also using a bunch of NLP resources that you can find out more about if you watch this video and pause it and read this slide. And I want to give you a bit of a caution that there's also some challenges here. So for example, we saw the word team in the passwords investigation. And we were really curious why people were talking about teams so much more in passwords than in regular language. And when we dove into the data a little bit more and drilled down, again, getting to reading the raw data, we saw this. Te amo, Luis. Jesus te amo. So this was actually just the I love you back again, but in Spanish. So we were assuming English passwords, but of course, not all the users were writing in English in their passwords. This one's from Barbie. But this is what she actually says. Chelsea would love to see your shell collection sometime. So I'm assuming, Chelsea, the shell collection that the child is telling Barbie about is really seashells and not weaponry. But so but the systems we're using don't have the ability in the small amount of data we have to disambiguate the meaning of this term. We have things like part of speech tagging where things change a lot. We also have open research challenges relating to the ambiguity of text, the volume of text, and things like the legibility. So we're doing a lot of manipulations of text. We're putting backgrounds on it, we're skewing it, we're rotating it, we're putting links between things, and we don't really know how we're affecting the legibility. So some of the research we've been working on lately has been partnering with people who do perception research to try and understand that a little bit better. Okay, I'll end there. Thanks to all my students. The ones in Boulder have work that was presented here today. Thanks a lot.